everyone, this is your math guru. In this video, I'm going to show you how to solve the following by applying the cosine rule. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. In the diagram below, PTSR is a parallelogram. The point Q is the midpoint of the line PR, and QS equals 6 units, PT equals 3 units, TS equals 8 units, and the line QT equals X units. The angle T1 equals to theta. We have to show that cos theta equals x squared plus 28 divided by 16x, and 2, determine the length of the line QT. Starting with the first part of the question, the triangle that is being associated with cos theta is your triangle QST. So I'm going to start by highlighting the triangle as shown. If I draw a quick extract as shown, that's the triangle QST. Then I'm going to tag each side. The side facing the angle T will be my small t. The side facing the angle S will be my small s. And the side facing my angle Q will be my small q. Using the cosine rule, I have, starting with the side facing the reference angle theta, I have t squared equals s squared plus q squared minus 2 times, the dot is multiplication, s times q cos the reference angle t. Putting in my parameters, I have t squared, that's 6 squared, equals s squared, s is x, plus q squared, q is 8 squared, minus 2 times s is x, times, I'm going to change the s to x, then I have times my q, which is 8, times cos t. T is theta. Simplifying, I have 6 squared, which is 36, equals x squared plus 64 minus 2 times 8 is 16, so I have 16x cos theta. The next step is to make cos theta the subject of formula. So I'll start by moving my 16x cos theta to the left hand side, makes it positive. So I have 16x cos theta equals, then I move my 36 to the right hand side. I have x squared plus 64 minus 36. Then I have 16x cos theta equals x squared plus 28, that's 64 minus 36, then dividing both sides by 16x in order to isolate my cos theta. I have 16x and 16x, that's 1. Therefore, cos theta equals x squared plus 28. I'm going to correct that, divided by 16x as shown in my question. The second part of the question says we should determine the length of the line QT. So I'm going to take off the highlight. I'm to find the length of QT as shown. So you can see that the line QT is part of the triangle PQT. So what I would do is to use the triangle PQT. I'm going to draw a rough sketch as shown. I have T, I have Q, and I have P. Note that because the shape PTSR is a parallelogram, and we know that the properties of a parallelogram opposite sides are parallel and equal. So I have the line PR parallel to the line ST. Likewise, the line PT is parallel to the line RS. However, I need to find the angle Q1. Q1 is equal to, I'm going to state that, angle Q1 is equal to angle theta, or T1, which is equal to T1, and the reason being they are alternate angles because the line PR and TS are parallel. So what that means is the angle at Q here is also theta. The line PT is 3 units. I have the line QT has been given as X. So therefore, to find cos theta, I've also been told that the line PQ is equal to the line QR. We know that opposite sides of a parallelogram are equal, so what that means is the total distance PR is also 8. So therefore, I have also the side PQ is half of the side ST, which is half of 8. That's half times 8, and that is 4 units. So therefore, I have this as 4 units and 4 units. So I'm going to write that in my sketch, 4 units. So therefore, writing an expression for cos theta, I'm going to use the cosine rule again. I start by tagging all my sides. The side facing my angle Q is my small q. The side facing my angle P is my small p. And the side facing my angle T is small t. So because I have the reference angle at Q, I start with the side facing the reference angle, which is Q. My sine rule states that Q squared equals, then I have T squared plus P squared minus 2 times T times P times cos theta, which is the reference angle, putting in my parameters. Q squared, that's 3 squared, equals T squared, line T is 4, plus X squared, P is X, minus 2 times T, that's 4, times P, that's X, times cos theta. I have 9 equals 4 squared is 16 plus X squared minus 2 times 4, 8x cos theta. So I'm going to make cos theta the subject of formula. So what I have is, moving that to the left hand side, 8x cos theta equals 16 plus x squared minus 9, dividing both sides by 8x. My cos theta will be equal to, I have 16 minus 9, x squared, that's plus 7, divided by 8x. So I've gotten another expression for the value of cos theta. Remember, in the first part of the question, we were able to show that cos theta is also equal to x squared plus 28 divided by 16x. So I'm going to equate these two expressions together, that is cos theta equals to cos theta, and what I have will be x squared plus 28 divided by 16x equals x squared plus 7 divided by 8x. Because I have a fraction on the left hand side and another fraction on the right hand side, I'm going to cross multiply as shown. So I have 8x in bracket x squared plus 28 equals 16x in bracket x squared plus 7. I'm going to solve for x. So if I expand the bracket, what I have is 8x times x squared. The term outside the bracket multiplies all the terms in the bracket. So that will be 8x cubed plus 28 times 8, that's 224x equals 16 times x squared, That's 16x cubed plus 16 times 7, 112x. And if I collect all the like terms on my left hand side, I have 224x minus 112x equals 16x cubed minus 8x cubed. I have 112x equals 8x cubed. Turning it into a proper equation, I move all the terms to one side, and then I equate to 0. I factor out my 8x. I'm left with x squared minus 14 equals to 0. So what that means is I have 8x equals to 0, or x squared minus 14 equals to 0. On my left hand side, I'm going to have x equals to 0, but remember, x is the length of one of the sides, so therefore I can have x equal to 0. But on my right hand side, I have x squared equals to 14, and to find the value of x, I'm going to find the square root of both sides. So I have x equals root of 14 units. Thanks for watching. Bye.